This is lesson 4.2, college algebra, starting on page 360. And the name of this topic is exponential functions and graphs. Not really too difficult, just quite a bit of information here that we'll see if we can get through pretty speedily. Page number 361, graphing exponential functions. Exponential functions are when we have a function that's written like this, f of x equals a to the x power, where a is a number bigger than 0 and it is not equal to 1 because 1 to any power is just going to be 1, so that doesn't really do us any good, doesn't take us anywhere. So a has to be bigger than 0, but it cannot be 1, which means it can be a number between 0 and 1, so it can be a fraction. And then it also has to be bigger than 1. So that's what our domain ends up being. All numbers greater than 0 but cannot be 1. And our x, x has to be a real number. It can be any number at all as long as it's real. It can be negative numbers, positive numbers, radicals, all that kind of stuff. Okay, so anyway, if you turn to page 362, it gives us an example, and one of the things it asks us to do is graph the function 2 to the x power. So really all you're going to be doing there is plugging numbers in for x, and it gives you a y, and you're just going to graph that. And this is what you'll get. As you start putting numbers in for x here, your y value will be doing different things. And so for this particular one, no matter what, if you put a 0 in for your x, you will always get a 1. So one of the things that will be true in this kind of a problem is it will always cross y equals 1. And as you put numbers in, you will find out that this graph goes like this. And as our numbers go negative, it gets closer and closer to the y-axis or x-axis, but it never touches. So if this x becomes 2 to the negative 3, that becomes 1 over 2 cubed, or 1 over 8. If it's 2 and our x is negative 6, it becomes 1 over 2 to the 6th power. So notice our fraction gets smaller and smaller as x approaches infinity, as x gets bigger and bigger, or I guess smaller and smaller as we go further and further left. My y value will get closer and closer to 0, but it will never get there. So as x approaches negative infinity, x approaches negative infinity, y approaches 0, but it never gets there. So in the last graph, we had a graph that looked like this. Okay? And that is if we have a graph where our exponent, and in this case, we had that. We had an exponent, or I'm sorry, a base that was bigger than 0. And also it was bigger than 1. It was the number 2. So what happens if we make a change here and we make our base, instead of 2, if we make it a number between 0 and 1, then it will make a change in what this looks like. It will change it to look like this. Okay? So it will change, it will reflect over the y-axis. So there are a couple things, top of page 364, that you need to know as far as properties of exponential functions. One we already talked about. F of x equals a of x, and 0, or a, has to be bigger than 0, and a cannot be 1. Another thing that we know is we know that the graph is continuous. There's no break in the graph, there's no holes. We know that it's 1 to 1. We know that the domain is negative infinity to positive infinity. We also know that the range does not go below the x-axis. In fact, it doesn't even touch the x-axis, so therefore we have a curved line or a parenthesis around the 0 showing that it never gets there. We know that it increases as if a is bigger than 1, and it decreases when a is less than 1, but also when it's greater than 0, so when it's a decimal, a positive decimal. We know that the horizontal asymptote is x-axis. And finally, we know the y-intercept, I'll put that right here, is 0, 1. It crosses the y-axis at 0, 1. Okay, that is if it's in this form right here. Now, once we start doing things to this, then some of this is going to change. Like all of this stuff will be the same, but the way the graph looks will change. Okay, so we're going to do some examples here. 4 examples, example 3, and we're just going to look at the main parts of those. So we're going to start out with a function f of x equals 2 to the x power. Okay, so let's bring this graph up here, and we'll see what happens as we do some stuff to it. So just f of x equals 2 to the x power gives us a real simple graph where it crosses at y equals 1, and it continues down, never hits the x-axis, but it continues, it looks like that. Okay, so what we're going to do, if you look at the first part, A, it says, okay, let's take that 2 to the x power, but let's make it 2 to the x minus 2. So my exponent is going to be x minus 2. What that minus 2 means is we're going to shift left or right, depending on whether that x is, or this is a minus 2 or a plus 2. Since it's a minus 2, we're going to shift it to the right 2 units. So this entire graph is going to move over 2 units. So now it's going to change to look similar to that. Okay, because it's going to move over 2 units, and one of the things I did is I took where the y-intercept was and moved it over 2. Okay, so that'll move over 2 units to the right because of the negative. If that were plus, it'd move it 2 units over to the left. Alright, so now let's see here. Let's take the next part and do something else to it. So again, we're still looking at our f of x equals 2 to the x power, and we're going to use our 2 to the x, but now we're going to subtract 4 from the whole thing. So the minus 4 is not an exponent, but what that tells me is, do I shift up or down? And again, depends on what the sign is right here on whether I shift up or down. So because it's a minus, we're going to shift it down 4 units. So I'm going to take my y-intercept, which is at 1, 1, 2, 3, I'm moving it down 4 units. Okay? So that means that my asymptote comes all the way down here to negative 4, and then I draw my graph like that. Okay? So I shifted down 4 units. Alright, let's look at another option. F of x equals 2 to the x power, but let's put a negative sign there. And let's just do what the book says. we're going to write that as 5 minus 2 to the negative x power. Okay, so I did a couple things here, 3 things in fact. I've got a negative on the x, I made this negative, and I added 5. This could actually be written as plus 5 over here, and that gotten rid of. So let's just do that. Let's put it on the other side. Okay, so that plus 5 means I'm going to shift it up or down. In this case, since it's a plus 5, I'm going to shift it up. The negative sign right here on the exponent means that I'm going to reflect it across the y-axis. And this negative sign here means that I'm going to reflect it across the x-axis. So it's going to do several things. It's going to go up 5. So that means my y-intercept is going, or my asymptote is going to be up 1, 2, 3, 4, 5 at the number 5. Okay, so it's there. My graph is going to flip over the x-axis and flip over the y-axis and end up being like that. Okay, so it's going to end up looking like this because this negative means that it's going to reflect across the y-axis, and this negative means it's going to reflect across the x-axis, and this plus means that my asymptote is going to move up, or the entire thing actually is going to move up 5, but it's easier just to move the asymptote up there to x or y equals 5, since it was y equals 0 when we were talking about this one, because it's a plus 0. There's nothing added to here, so my asymptote is going to be the x-axis. Alright, so let's try one more. If we had, let me get rid of that, if we had f of x equals negative 0.5x, whoops, x plus 1. Okay, the thing that makes this one a little bit more difficult is all these other ones that I had up here, I've got, they look like, get this working here, they look like this, 2 to the x power. We just did things to the 2x, but the 2x stayed the same. Now this changed. So what we're going to do is we're going to try to rewrite this so that it does look a little bit more like 2 to the x power. So what we're going to do is we're going to change this to negative 1/2 to the x power plus 1. Well, that looks a little bit closer to 2 to the x power. Now we're going to take and make it 2 to the negative x plus 1, because this negative sign, remember, says that my 2 is in the wrong place, that it should actually be in the bottom here. So I moved it up to the top, so it's 2 over 1. So I have to put a negative here to show that that 2 is actually supposed to be in the denominator position. That negative stays the same, that x stays the same, and it stays plus 1. So now it's written in 2 to the x form. So now at this point I can look at the 1 and see that my asymptote moved up 1. It shifted up 1. I can also see that because of this, I reflected across the y-axis, and this here tells me that I reflected across the x-axis. Okay, so that is the first part, 4.2a of the lesson 4.2, and we'll get into 4.2b, which starts on page 366 on the next video.